Today's topic is going to be representing of algorithm. Yeah. So we're going to talk about the ways how we can represent algorithms, and we are going to cover writing algorithm in Pseudocode according to AQA Standard, how to create flowchart, how to translate algorithm into Python code. We're also going to have look at few practical examples here. So let's start. The first thing, as I mentioned, we're going to talk about writing algorithm in pseudocode. So first of all, we need to figure out what is pseudocode. Yeah, so we particularly mentioned it last time during previous session, and we know that this is some kind of description that allows us to specify or describe the algorithm in some specific, not very strictly programming language way. Yeah, so we don't need to worry about the syntax or any possible issues that could come up when we are using programming languages. And let's have a look at simple example. So here we can see there is some begin and there is some end, and this would specify the beginning of the program and the end of the program. We would have two numbers for input. We would have some variable sum that is storing the sum of these numbers, and we would output this sum. Yes, as you could notice in the beginning of previous slide, yeah, I paid attention to AQA Standard, yeah, because again, you're going to do AQA exam, so it's important to follow their standards. There are many different ways how you can define pseudocode. It can be human-described language. We're going to talk about this today as well. It can be, again, AQA standard. In universities, we're going to talk about different standards. Today, we are going to focus only on those that is required for AQA standard to successfully pass the GCSE exam. So let's have a look at some key features of pseudocode. We have already mentioned them before, sorry. And again, this is just plain language. No need to care about strict syntax. It is a logic flow, yeah, so it describes the order in which the algorithm is going to be executed, and we skip implementation details, and we are focusing on what's happening now and what's implemented now, how to implement it. Yeah, and so let's have a look at more examples of some pseudocode. Let's try to solve the next problem that is asking us to write pseudocode for finding maximum of 3 numbers. Yeah. So what would be the first thing that we would do when we are talking about finding the maximum out of 3 numbers? Yeah. So we would assume it would be, let's say, numbers A, B, C. So we would compare first number with second, first number with third number. In case if the first number is larger than both of them, then we are going to print first number. In case if the second number is larger than first and third, that we are putting the second number to output. And then in case if the third number is larger than the second and first, we are printing it. Yeah. So let's have a look at the example of pseudocode, how it could be written down. So we can clearly see there is a begin and input here. Let me have a look if I can use. Can I? Second, no. No, unfortunately, I cannot use this tool here yet. So yeah, we can clearly see that there is beginning of the code and there is end of the code. Yeah, so this kind of pseudocode is not perfect to our AQA standard. And we are not going to talk about algorithm or approach quality. Yeah, so we are not going to talk about most efficient algorithm. Our task today is to learn how we can convert our ideas, our problems into pseudocode. Yeah, so we can see here, we are inputting 3 numbers, yeah, which represent number A, number B, and number C. Then the next step, what we are doing, we are comparing the first number to the second and to the third number. Yeah, as I mentioned before, in case if it's larger, we are printing this number out. Otherwise, we know that the first number is not the largest out of them, then we can just compare the second number to the third number. In this case, we can print out B in case if this number is large. Otherwise, we can print out the third number, the last option. Now, what I suggest us to do now is to talk about flowcharts. Yeah, so let's try to draw some simple flowcharts. We already tried to do it during last session, I'm sorry. And before we mentioned that these are diagrams that usually represent the sequence of steps in an algorithm using some specific symbols. We mentioned during last session that ovals usually represent what beginning or end of the script. Rectangles usually represent processes, and diamonds usually represent decision tree, yeah, decision making point. So today we are going to have a look at some flowcharts. Yes, so again, they are going to be helpful because they are showing us the way how we can implement algorithms, starting from initial point to the end point. Yeah, and let's have a look at simple algorithm. Yeah, so I have shown this flowchart during the first session. Again, it's not following the standard that I described before. It's usually up to you. Just you need to make sure that what you're showing in your flowchart is clear to the person who is going to read it. Yeah. So it's clear here that we have some starting point, we have ending point, we have some decision point. We have some decision point, and yeah. So now let's have a look at some proper examples of flowcharts. So again, we have just solved the problem of finding the largest number out of 3 numbers. Yeah, so let's try to convert the pseudocode that we had before into flowchart. So let's see what we have here. We clearly can see that we are having what? We are having the start point, yeah, and end points. I prefer to use blue circles to show that this is either start or yeah. Then we have 2 decision points. As you can see, the first decision is made when we are comparing A to B and comparing A to C. Yeah. So in case if the condition is met, we don't need to do anything else. So we're going straight to the end of our program, and we don't need to compute anything else. In case if we did not match the condition, we have 2 more conditions left. So the first condition, we are checking if B is larger than C. And you can see there is some little glitch that shows 3 output A's. Yeah, so actually, in case if B is larger than C, the output would be B. In case if it's not met, output would be C. Yeah, so when I'm going to post the presentation for you, I will fix this issue. Yes, so any questions about this flowchart? I hope everything is clear here. I'm reading chat. No questions, no messages on chat yet. Okay. Okay. Yes, Jayton, I can see a message on chat. Yeah. It's a glitch, so it should be A, second one B, and then C. That's correct. in the final presentation that I'm going to upload for you, the issue will be fixed. Yeah, so since there are no problems left, we can now see how we could convert pseudocode into Python. First problem again, we are going to talk about finding maximum of 3 numbers into Python code. Here we are assuming that we know and understand some Python, how it works, some basic syntaxes, yeah? So, again, important thing that we need to know about Python in this context, how to input data correctly, how to output data correctly, how to write down if, else, or elif condition, and not to forget about indentation. Yeah, it's one of the most important things when we are talking about Python syntax. So let's see how we can achieve it in Python. So first of all, we would, again, define 3 variables that would be storing data for 3 different values that we are entering from the keyboard. Yeah, as you can see, square brackets matter as well. Yeah. And then after we entered 3 values, A, B, and C, we are going to implement our algorithm, the one that we described before in Pseudocode and in Flowchart. Yeah, so we are going to compare if A is larger than B and A is larger than C, then we are doing the print. In case if the first condition is not met, we are moving to the second condition. Yeah, B larger than C. In case if B is larger than C, we are printing out. In case if this condition is not met, we are moving to the third conditioning. Yeah, so let's have a look at the flowchart again. Yeah, so again, first condition is met, then we are moving straight to the output. In case if first condition is not met, we are going to jump into second condition and check it twice. Yeah, so in case if it's true or false. So yeah, this is pretty much all of this code that we would be using to check which one of the 3 numbers is large. Now let's have a look. Have a look at the difference between pseudocode and Python code for now. Yeah, so as we mentioned before, pseudocode, again, language agnostic, there is no strict syntax. Yes, so this is basically plan, skeleton, so I prefer to call it, for algorithm or plan of Python code. It's exactly the implementation of our algorithm, the plan that we are following using Python programming language. Yes, again, let's have a look at table comparison, similar one that we had during last session. So in terms of syntax, pseudocode does not have any strict syntax. Python code requires properties. Again, pseudocode can be written in any plain language. Python code is using Python language. And obviously execution, there are no execution for pseudocode. For Python code, we're using computed or whatever device you prefer to use. To execute the code. Now, we are going to have a look at a few predefined examples, practical examples, to work with converting everything step by step. So let's define the first. Sorry, there is one more step. I also wanted to show you a comparison of flowchart, pseudocode, and program. Yes, so as you can see, pseudocode and program are very similar to each other, yeah, in case if you are following strict examples. But all of them are following flowchart. Yes, so in my opinion, before you start writing any code and you are not 100% confident in your programming skills, I would always recommend to start with flowcharts. Yeah. Once you understand step by step how you are going to, what you are going to do, what decisions you need to make, where you need to go back to another decision, what you need to double check again. Once you have everything sorted out, then you can write pseudocode and then you can write implementation of real Python code. Yeah, it will help you to avoid many unnecessary issues and will save a lot of time when some issue arises, when you need to debug, to test your code. Yeah, we are going to have different sessions about this with all of the advices, how to improve the quality of your written code and your programming logic. Now, let's have a practical example. The first one is going to be converted temperature. Yeah. So let's say we have stated the problem that we want to convert temperature from Celsius into Fahrenheit. Yeah. So again, there is another approach that I recommended you before, that before writing any kinds of code, pseudocode, writing a flowchart, flowcharts, you can use human explanation to understand how you would explain the algorithm to your mom, to your grandmother, to your 5 years older sister, the person who does not know anything about code, how you would explain to them how your program works step by step. Yeah, so again, in case we want to get information from the keyboard, we need to get this information from somewhere. So the first thing would be displaying a message to the user, asking the temperature in Fahrenheit. Yeah. Then the second step, we would be storing this value that we entered in Fahrenheit. Yeah. Then we are using the expression. Again, I found it on Google. You can also find it. You don't need to explain why it works that way, how it works. It's just a fact. Yeah. So we are using the given expression to convert it from one temperature system into another temperature system. And after we converted it, we are doing what? We are displaying the result of our converted temperature. Yeah. So let's have a look at this pseudocode, what it would be looking like. Yeah. So again, the first step, we are displaying the message, yeah, asking us to enter temperature in Fahrenheit. Next step, we are storing the value from user input in Fahrenheit. Yeah, so here, as you can see, we are strictly following our AQA standards for writing pseudocode when we are writing this arrow forwarded to the left. It basically means that what we are storing a value from keyboard, user input, that's what we are entering from display, and the variable called Fahrenheit. All arithmetical operations are pretty same as in any other programming language or in the way you are using it in math. Yeah, so we can see it in the how we are storing it in the variable Celsius, and then we are displaying temperature in Celsius. This is a message, and then we need to add comma and the variable that we are going to show after the string variable. Yeah. Now, after we have pseudocode, we define pseudocode, yeah, so we can double check our logic using what? Flowchart. Yeah, so there is some glitch asking to enter temperature in Fahrenheit in the end. Yeah, so we are going to fix it as well. So again, the first step is enter temperature in Fahrenheit, then we are storing the value in Fahrenheit, then we are converting to Celsius, then we would need to print the value in Celsius. Yeah. So, and let's see what would be Python implementation. Yeah. So we are assuming it would be what? Some number. We don't know if it's going to be the value with floating point or without floating point. So just in case, we are converting it to floating point. Yeah. Then we are second step. We store the value. We converted it into Fahrenheit. And the third step, we are printing the value. Yeah. Let's have a look at a few more examples, more complicated examples. So the first step now would be comparing numbers to 0. Yeah. So we know that we can compare a number to 0 in what? In 3 different ways. Yeah. So the first output of comparing number to 0 could be if number is larger than 0, then it's positive. In case if number is less than 0, it's negative. And in case if number is equal to 0, it is 0 itself. Yeah, so how would we explain it in a human language, this part? Yeah, so the first step is obviously we are displaying some message to user to enter the number, then we are entering the number. After that, we are going to check if the number is greater than 0. In case it is, we are saying, okay, it's positive. Otherwise, we are dropping into 2 more possible conditions. Yeah, we can compare it. If it's negative values, then we would say negative. Otherwise, we are having just one final decision left, which is going to be just value of 0. Yeah. Yeah, so and pseudocode. Okay. So we are displaying the message, yeah, which is antenna. Then we are asking about input that we are storing in a number. In case if number is larger than 0, then we are outputting positive. Then in case if it's less than 0, we are saying negative. And in opposite case, that does not satisfy any of these two, we are just saying. Yes, so let's have a look now at the flowcharts. After we understand human explanation, we assume that our pseudocode will be working right. So let's double check our logic with a flowchart. Yeah, so again, in the beginning, we start, I'm using the circle, then we are using parallelogram to enter number, then we are going to check the condition if a number is larger than 0. In case if number is larger than 0, so what we can see there? In this case, we can then move to end straight away. We can move to end straight away, and can I show it? No, I cannot. Okay. Then, in case if the condition was not met, number is larger than 0, then we are dropping in another condition. We are checking if number is less than 0. What happens in case if the condition is true? We are outputting negative value. In opposite case, we are just saying output 0. And we can see all of the 3 ways they lead to the end of the execution process. Correct. If you write the leaf comparator. Yes, coming back, this is a good question. Yeah, so you can say a leaf. Yeah, a leaf, it's like a more Pythonic way. There are other languages that are using a leaf as well, but you can use any version, else, if, or a leaf, and the examiner will understand that you're talking about another condition of it. Any more questions about pseudocode and else? Yeah, the arrow has to fetch the identifier, which is variable in your current case, to show that you are storing the value. Yeah, so when you are saying a number, arrow stored to the number, you are saying that you are going to store exactly in this variable, exactly in this identifier, the value. Well, in case if during exam you are putting equal sign instead of the forwarded arrow, it will be up to examiner, but to give you a mark or not, again, it depends on the examiner. I would personally wouldn't mind, sorry, if a student would put just equal, because I understand what the student is trying to say. Yeah, so, but examiners can be quite strict when it comes to the standard. Yeah, so there is very strictly defined standard of AQA. So they tend to ask students to follow the standard. Any more questions? Let's see questions. Yeah. Again, both are correct. Both are correct because again, pseudocode is not having some specified syntax, yeah, in comparison to programming languages. In our case, we are talking about AQA exam board, yeah, and they have their standards and requirements, yeah. So that's why at the beginning I showed you one way how you can define the pseudocode, and now I'm showing you the exactly way that the exam board is asking you to write it down, yeah. In any like non-exam case, both are correct. But during exam, I would recommend you to separately use 3 different identifiers where you are storing the value. When you are writing down column instead of then, you're referring to Python syntax. Yeah, keep in mind that not every examiner in AQA exam board is 100% familiar with Python syntax. Yeah, there are examiners that never seen it before. They use Java, they use Basic, they use C#, and they would not know what you're trying to say when you are using columns. Yeah, so it's better to use then. In case if you are using then, it's 100% clear that you're trying to say the next section. Okay. So I guess we can move on. Yeah. We were comparing numbers. Yes, so let's have a look at simple implementation. Yes, so again, it's barely any different to our pseudocode. We compare the number to 0. If it's larger than 0, then we are printing out positive. In case if it's less than 0, then we are printing out negative. Otherwise, we are just printing out 0. Yep. Now, let's have a look at the next example, which one is going to be a bit more interesting. We are going to find the total value, some of the first positive numbers. Yeah. Here we already need to use what? We would need to use loop. Again, in Python, we know that there are a few types of loops in different programming languages, such as even Pascal, in C++, Java, there are 3 different types of loops. But for pseudocode, for now at least, we are going to use just one. So now let's start with the next thing. Yeah, so what we usually do, we are trying to define human explanation. Yeah. So so the first thing, we are obviously prompting a message to ask user to enter some positive number, and after we've done it, we would store the value somewhere. Yeah, as you can see here, I made let's say unconscious mistake here because I started moving a bit away from explaining it in a simple way. Yeah, so I started using like programming definitions, using variable, initializing variable to store, set counter, etc. Yeah, so there are obviously simpler way how to describe it, but yeah, we're assuming we understand each other, so we know that we can store the total value somewhere, and we are going to use something to count the number of numbers that we still need to add. Yeah, and we are going to repeat all of these numbers, all of these processes. Until we reach the value of n. Yeah, until we finally got to the final value. Yeah, and we are going to do it by doing what? By adding our counter value to our total final value, and we are going to increase, or in current case increment, the value of the variable that is storing our counter by 1 at each step. Yeah, and once the loop ends, we are going to display the value that we've got in there. Yeah, so let's have a look at pseudocode. Yeah, so again, in the beginning, we are asking to enter positive message. Then after we've got user input, we are storing it in variable n. We are defining that the variable we are going to use to count all of the values, and is going to total sum is going to be equal to 0. And we are going to start with the first number counting. We're making it equal to 1. And now we are going to use while loop. Yes, so in Python, you know that you could use for loop for auto increment, but point is in most of programming languages such as C++, C#, Java, regular C, when even we are using for loop, you need to define increment action as well. And we need to define condition there as well. Yeah, so here we have condition. We have clear condition. We are going to increase our counter, until it reaches the value of n, which is the value entered from the keyboard. Yeah, we remember that n is number of the first positive number that we want to sum up together. So while the condition is met, the count is not larger than the value of n, we are going to update the value of our total sum. Yes, so we are storing total sum, and then we are updating the total sum by adding value of I to it. And we are also incrementing the value of I at each step. And then we can see after we finish the while, we are saying end while. Yeah, so we were doing the same thing with if, and if we are ending while as well. And then in the end, we are just outputting total sum. So now let's have a look how we could convert it into a flowchart. Yeah. So again, first couple of steps are pretty obvious, I believe. That start, entering positive number, declaring variables. But then we come to the condition. Yeah. We come to the condition where we are checking the numbers. If variable I is less or equal than it. Yeah, and we can see we're having two processes that are strictly defined there. It's increasing the value, updating the value of total sum variable and updating the value of variable stored variable I. Yeah, and we're repeating it, looping, circling over and over and over again, as you can see. And in case if the condition is not met, we're just outputting the value. That's the end of our program. And now let's see how we could implement it in Python. Yeah, so again, we would just enter Ramen is the do until yeah, so basically do until is pseudocode with post condition, while loop is a loop with precondition. Yes, so you could have said, actually I'll show you how to work with the diagrams a bit later so we can talk about this, how to implement it. Yeah, so here we are checking the condition and doing the following some processes, but in do until you will do the process and then check condition. Yeah, so let's quickly have a look at the code. Yeah, so again, we are defining integer value. Yeah, we need to keep it in mind that it cannot be float. Well, technically it cannot be, but again, positive numbers. Yeah, we are checking only integer value. Yeah, so we are defining, initializing two variables where we would be storing the data. Then we are using while loop to, again, check the condition that our count is less than our number. Then we are updating our value over and over again. And then in the end, obviously, we are just printing out the result. Questions, please? No questions yet, I believe. Okay. Okay. So now this part is going to the end. Yeah, we are going to have two more parts. So so today we had a look at how pseudocode works, how flowcharts works, how we can convert it into all of the Python. So we can say clearly that pseudocode, they're simple and easy to write and share. Flowcharts, they're really great for visualization of steps of our algorithm. Python is obviously execution of our program. Yeah. And all of them can be combined for what? For solving our, yeah. So next lesson, I don't know why it's not updated. Yes, so we are going to work a bit more on writing algorithms to the code, creating a flowchart. Yes, so I feel like today we have considered basic algorithms. Next time we can speak about more how to work with subroutines, with lists, etc. Yeah. So what I'm going to show you now, yeah. So this is basically the end of our lecturing part for today. So for now, I'm going to show you a few tools. What I would recommend you to use for working with flowcharts and for working with working with flowcharts basically for now. So I can stop sharing screen. Yeah, how do I do it? Can I do it from here? Yeah. Okay. Now, let's have a look at the first resource. I feel like I'm going to leave the link either on presentation or video description or both. So let me know, please, if you can see my screen. Yeah, you can see the screen. Perfect. Most important. You can see. Okay. So yes, you can see most of the graphs, flowchart that I have prepared for our today's session, previous session. I've done it using this platform. Yeah, you can see like you can do anything. Like you can prepare mind maps here. You can use basic algorithms, basic flowchart, basic step-by-step solutions. Yeah, the most important thing here, why I really like this platform, is that they allow you to use flowcharts. Yeah, so for example, you can define how to use it. Yeah, so let's say create a flowchart. Create a flowchart to choose the largest out of three numbers. Yeah, again, it's not going to be perfect. Yeah, I can make separate video about how to do a problem prompting for getting proper output. Yeah, so we can try to get another prompt. Yeah, make sure that the start and up blue circles. And let's see what it's going to show us. Yeah, so you can see once you redefine your prompt, deeper is going to show you better example, better. Yeah. There is also more advanced thing that I have worked on within the last couple of days. Yeah, I have defined some LaTeX code. I have defined some template. Again, we have not spoken much about markup languages such as HTML or Markdown code yet, but this is really very easy and quite intuitive how to figure out how it's working. Yeah, so I was using it for previous session, for this current session. again, I can implement it for use. Yeah, I'm going to take notes of today's session. I'm going to use this tool so I can share the link with you where you would be able to plot and put any tag that you would like to. Yeah, so it's very, very easy to customize it. Instead of, yes, you could say random texts. Basically, the only thing you would need is to change the value in square brackets. Yeah, so as you can see, test, let's say another test. Yeah, then you are recompiling and we can see the value is changing. Yeah, so it's quite easy to work on this. I will share the links with you a bit later. And now, what we are going to do? Now we are going to work on some pseudocode examples, some pseudocode exercises. Let me quickly reshare another screen with you. Let me know again, please, if you can see my screen. I feel like I need to zoom it in a bit so you would be able to see it better. Yeah, you can see it well. Okay, so again, for pseudocodes, we can use, again, any AI assistant that would allow you to use a pseudocode, or you can use Google Docs to create pseudocode. Yeah, I, for example, personally installed the next extension that is called Code Blocks. Yeah, so let me show you one of the pseudocode that we use today. 1 second. Let this go. Yeah. So in case if I have some plain text here, let's hit. I have this kind of a plain text, and I want to make it look a bit more beautiful. Yeah, I would just select all of the case, all of the text, and we can use. I would use Arduino. Unfortunately, I'm not sure which one. If it's going to be this one, again, you can play around as much as you want to. Oh, that's ugly one. That's very ugly one. Yeah, let's have a look. Maybe VS Code 2015, maybe. Yeah. So this is pretty much more similar to what we were working on before. Yeah. So now I have prepared quite a few problems for us to work on together. That I'm willing that I want to show you actually. So let me find the first one and then we are going to start. Yes, so as I promised before, now sessions are going to be a bit longer than the first one. We are going to split. We are going to split our part. This is headed to. We are going to convert into heading 3. So for those who are not familiar with these tricks, these are going to be programming basics. Let's turn it into programming. Yeah, so I'm using the headers, so we would have the outline table at left, and then it would be easier to go through the file content. Yeah, so the first exercise would sound the next way. We would need to to define a sum of two numbers. Yeah, and let's try to write pseudocode in real time. How we would be able to. Yeah. So what would we need to do? So the first thing we would need to enter what? Enter the first, yeah. So let's say it would be a number, but we are going to enter two numbers and we are going to compare two numbers. So the second step we would do would be what? Asking user to enter the second number. Yeah, let's say it's going to be number B. So, and as you can see, I'm using this arrow to state where I'm going to store the value. Yeah. Now, okay, we can now get rid of this. So now we need to find the value, and let's use to declare whether the no, you don't need to declare the data type of the variable. Again, this is pseudocode. This is pseudocode, so you don't need to do it. And now total sum is going to store what? A plus B value. Yeah. I believe that this is pretty easy to do. Yeah. Let's have a look at the second exercise. Yeah, first two exercises are going to be simple. First two, maybe even three, and then it's going to be way more interesting. Yeah. So again, let's copy the first and second part. So the second exercise is going to be about calculating the area of a triangle. Again, we know from math that to calculate the area of a triangle, we need to know what? Two values, the height, the length and the width of the rectangle. Yeah. So let's ask user to enter the length of the rectangle, and then yeah, so now let's be a bit more specific about what we are entering, not just using regular variables, because again, it's very easy to forget what you're talking about. So I always recommend to everyone, and it's actually required by many of the standards, to declare variables in understandable way. Yeah. So even in AQA standards, yeah, they require you might use one or two marks in case if your variable naming is not properly defined. So, and what we are saying, area is going to be the result of multiplication length and width. And then we are going to what? To output the area. Yep. Area, we can even make it look a bit better. Oh, let's copy this string message. String message. Oops. The area is something. Yeah, I believe it's pretty simple for you. No questions. So now, now let's save the example that I was using during our lecture part. Yeah, so compare a number to 0. And again, let me show you how I'm doing this. I have already defined code block from our extension. Yeah, and I'm using what? I'm using Arduino language and theme vs. And yeah, okay. Let me show you what happens in case if we are changing a language. In case if we, let's say, using a Python. Yeah, you can see it's not going to highlight what you need. We can try to use, let's say, Bash. Yeah, it is the language used in terminal. Yeah, cannot identify everything either. There are other languages such as Mathematica. Let me quickly have a look if it's here. Mathematica. So not everything is really doing well with different languages. So again, my choice is to use Arduino in case you want to have beautiful highlights of the language. Obviously, you would need it for exam, but again, you can have it for own practice. Yep. Now, there is one problem that I love so much. We are going to get a grade based on marks. Yeah, so as you might be familiar with this problem, it would require us to do what? To enter marks. Yeah, let's copy it. Enter marks from 1 to 100, and then we would be storing them. And then we would try to solve this problem. Yeah, how would we try to solve this problem? We would need to compare at each step. Yeah, we know that in case if it's larger than 90, it's going to be grade B. It's larger than 75, it's going to be B. If larger than 60, it's going to be C. Larger than 40, yeah, it's going to be D as far as I remember. Otherwise, it's going to be F, E, etc. So what we are going to do? The first step, we are going to compare marks. We are saying larger or equal. Then we are outputting what? Grade A. Yes, so again, you could write down that marks is greater than marks is less than 100. But as you remember, there is not necessary to check this condition. You just need to check that this is larger than 90. And we are doing what? We are just, let's use this slang definition. We are just spamming with this condition again, and again. Yeah. So here we would have what? Yeah. Let's copy our highlightings. Would be what? You also do. Yeah. Good question. Yes. So you can also. You can do it. You can write down the next thing. You can write down the next thing, but there is no point to do it in case if we know that it cannot be larger than 100. Yeah. So we are assuming that we entered a value between 1 and 100. In case the task does not require us to check if the value was entered correctly in correct range, we do not need to double check it again. But yeah, it could be done as well. Yeah, so what was the next step? The next step was like, let's say 75, grade B. So we are just doing all of these things. So how much we are going to go until 1, 2, 75, 60, 60, let's say would be C, 45 would be D, else it would be great. Yeah, and I hope it's going to be pretty much. Any more question about this exercise? Question. No questions. Now, let's have a look at a more interesting thing, which is loops. Yeah. So for and while loops. After writing pseudocode on loops, I'm going to show you how to do the part with do until. with do until. Actually, we are going to do it for both ways. So now we are going to talk about for and while loops. Yes, so that was selections. Now for while loops is going to be exercise 5. And now let's save sum of numbers from 1 to n. Yeah. So this is basically the problem that we have solved before. But now we are going to alter this a bit because we used while condition in the example in lecture, but now we are going to use for loop to complete the action. How would we do? Yes, so let's define enter number, let's say number n. We would store in the variable number, and let's say we would define a total sum variable, which would be in the beginning equal to what? Now, most interesting part. How would we define for loop? We would say for I equal to what? In the beginning, we say it is equal to 1 to number. So what does it mean? We are saying for values of I starting from 1 until it reaches the value of number, we are going to perform some task now. Yeah, we can get rid of this part now. What we are going to perform, what we are going to perform, we are going 1, 2, 3, 4. Yeah, I recommend to use 4 indentations. So we are going to update the value of total sum by value of, yeah. And do not forget about important thing. Yeah, every single operation should be ended. Yes, so again, in programming languages such as C, C#, C++, Java, some other languages, we are using curly square brackets to open and to close if statements, for statements, while statements, etc. In such programming languages like Visual Basic and Pascal and Delphi, we are using defined statements begin end, as well like in pseudocode. Yeah, so then we are just doing what? Then we just need to write down the output. Let's say sum is, and sum. Sorry, total sum. Total sum. Yeah. Yeah. Oh. Sorry. Glitching. Yeah. Now let's try. What was it? Do until. Let's write down. This is 5A using do until. So we can keep the core. Are you allowed to define a variable during? This is a good question. So yes, you are allowed to define a variable during loop statement. Yes, so we are defining the variable in for loop. Yeah, it's basically the same as in Python or any other programming language. And as Shramin is saying on the chat, it would be local scope. Yeah, so what is a local scope? It is a scope where like variable exists particularly, but not in a full program. Yes, so it exists only in that part of the code. Yes, so the variable I, it exists only in these 2 lines. it does not exist anywhere behind those two lines. Yeah, so it's called local scope of for loop. So yeah, you're allowed to define it right here. Yeah, welcome. Yeah, so now let's try to solve it using do until condition. Let's move it up. So beginning would be pretty much same. Yeah, I would say. Yeah. So number is same, total sum is same, but we would obviously need to take it out from for loop. We would keep it here. Then we would be saying do what we are going to do. We are going to increase total sum. What else we are going to do? We are going to increase the value of I by what? By 1. And how long we are going to do it? We are going to do it until I is larger than number. Yes, so we are going to do it until the moment we are bumping that I became larger than number. So it's post condition. Any questions about how until works here? No questions, I believe. No questions. Yes. Now, we can have a look at another example. Let's have a look at a more complicated example that can be asked as well. So it would be a print multiplication table. Let's use capital multiplication table. Let's copy this code that we had before. And use this code to change. Oh, let's reapply. Yeah, so let's say we are entering some number. Yeah, again, nothing really changing. And let's say we would like to print out the multiplication table from what? From 1 to 10 for n values. So we can, in for loop, here, we can define a number as well. So instead of variable, we can put any number here as well. So let's say we are going to print values from 1. Sorry, we are going to work out the values from 1 to 10. And then we would be doing the next thing. We would print. Yeah, so this is exactly the case when it's better to use short name. Yeah, so it would be not very useful to use it here. Let's say we would say n times what? Times this value of I would be equal to what? Result of multiplication n times, sorry, capital N. Yeah, need to be really careful with this because lower uppercase, it matters as well. Now, since we know how for loops work, there is a very interesting question to you. How would we find sum of even numbers from 1 to 100? Yeah, so let me write down the task. Yes, so it would be sum of even numbers from 1 to 100. Even numbers from 1 to 100. I'm curious to see on the chart, in case if anyone have an idea, you can write it down in one sentence, or if you don't want to write it down, you can raise your hand up and share your solution with us. Don't hesitate to do so. Yeah, so Ramin said we can use a modulus operator to see if the remainder of a number is equal of remainder of division by 2 is equal to 0, then we can add only these numbers. Yeah, good one. But what else we could do to achieve to reach only even numbers? Yeah, I'm giving you a hint since we are working with for loops. Okay, Alex suggested to go from 1 to 100, and Alex is suggesting to check remainder after division by 2 to 0. Yeah, otherwise return no. Okay, I'm going to correct it. Alex was quite close, but let's see. Let's see how we would be able to correct. So, in the beginning, again, let's say we have some variable sum. Let's use total, yeah, instead of sum, because we know in many languages sum is predefined function, so it's better not to test it. Now, again, we can start directly from 2, yeah, because of 1, because we know that 1 is odd number, so there is no point to start from 1. And in case if we start from 0, again, there is no point to start from 0, because what? Because we are adding 0 to total number is not going to change the final output. And here, we can use some very interesting trick. We can say, let's use step 2. So what would it mean? It would mean that we are just using a step 2 for number I. We are going to add the values only with step 2. So we started from 2, then we are going to 4, then we are going to 6, then we are going to 7, etc., etc., etc. Yeah, now let's have a look. What's going to happen if we are going to use if statement with modulus? Yeah. So let's define it like 7a, and this is going to be 7b. Would work? No. Plus equal. Do not write down plus equal in pseudocode because not everyone knows what it means. So again, for step here, mod. So yeah. So again, if we are going to use yeah, so most important thing is how to write down the condition for modulus. Yes, so we know that we can use percentage operator in Python, but how would we use this modulo in pseudocode? In pseudocode, we would say if I mod 2 equal 0, then yes, so mod comes from modulus, yeah. And yes, so we do not need any else. We do not need any else statement. Yes, so we are just updating this one. Yeah. Let's add one more important thing. Total of even numbers. To be equal to what? Yes, of course you can use step in Python as well. Yeah. So that's why Python, we're using Python, so we can avoid this unnecessary if condition. Any more questions? Now, we have already started talking about mode, but there is another important thing, such as division. Yes, so integer division. So we know that in Python, we would use real division, integer division by using double. Now, let's try to solve the next problem. Give me a second. Now, I hope you can see me better. So, one of my favorite problems for beginners, so it would be find sum of digits in a number, so here, again, there are a few ways how you can solve it, especially using programming languages, but let's assume we don't know any programming language, and we just know how to do pseudocode or how to use flowcharts. Actually, we are going to convert it into flowchart as well. So what we are going to do here, obviously we would need to enter a number. Sorry, I forgot to get rid of this input here. It's more aesthetically beautiful. So what we are going to store our number here. It's going to be what? Input. We initialize total value. And then what kinds of loop we would use here? Obviously, we would need to use while loop. But what would be the condition? We would be writing down the condition while number is larger than 0, do. What would we do? We would extract digit. We remember, how do we usually extract last digit from a number? We need to divide it by what? We need to find the result of remainder division by 10. Yes, so in case if we have number 1, 2, 3, and we divide it by 10, we have result 12 and remainder 3. Yeah, so we would say that the value, yeah, auto replacement is not working, so we're going to write it down like this. Number mode what? Mode 10. Let's reply our language. Apologize. Yeah. So it was modified. Yep. Now, what we would do, we would need to update the value of total by adding the value that we just got from our digit. And next step that we are going to do is update the value of our variable n, the one that we just entered from the keyboard. How would we update it? 1, 2, 3, 4. We would say that we are going to divide the number by 10. How would we divide it? Like integer division. In pseudocode, it just div. Integer division by 10. Here we are. And in while loop. And we can total of sum of digits number is equal bottom. Let's double check. We did not miss any syntax. What exactly are you talking about? What kinds of symbols? Yeah, of course. As you can see, we are doing it. We are using it right here. But also, again, you can use basic operation. Because a double slash, yes, double slash, let me show you. This is Python, yeah? In Python, it means, integer division. Also, this means modulus in Python, yeah? But in also in Python, there is this interesting symbol. And when you can mistakenly think that it would mean power, it does not mean power, it means XOR. And in Python, for example, to get power, we are using double asterisks. That's why, like in different programming languages, they're using different symbols for different operations. That's why basic for operation, they are the same for pseudocode, but something more specific is defined in this way. Yes, so, and if you want to write down power, you would say power x, for example, to power of 2 in pseudocode. Welcome. Welcome. Yeah, so, and now let's quickly try to draw the flow chart for this exercise. Let me think. It's right here. And let me show you how we can draw the flowchart. Yeah. And everything is going to be quite simple. Where is it? Let's hide it. Yeah, perfect. I hope you can see it well. Let me check if I can make it a bit larger. No, was not that helpful. 70% should be better. Yeah. So positive numbers, we got positive number, then we are, what happened here? Weird glitch here. So we are defining total variable, a total variable that is equal to what? It is equal to 0. Then we are also defining, copy it actually. Yeah, it looks aesthetically way more beautiful than this. So what do we need to define? We don't even need to define y variable. Yeah. So we are going to check the conditions straight away then. Yeah, so again, for condition, we are using what? We are using trunk. And what is our condition here? Our condition is to check the number. Okay, here we need to be careful because I was not consistent with my variable naming. Yeah. Number, let's call it number, not n. A number. Yeah, so we need to check that our value stored in the variable number is still larger than 0. Then we are having 3 processes that we are going to do here. Yeah, the first one, we are defining a digit in local scope of the loop, yeah, which would be equal to what? Number mode 10, yeah. Then we are updating the value of what? Of total. By saying what? No, total is equal to total plus digit. And then the last step would be what? Would be to change the value of number. This is a good question. What happens if we perform modulus on negative numbers? So what would be the remainder of division -5 by 2? What do you think? 1, yeah. Yeah, it would be positive, a positive remainder. Yeah, so basically in programming, pretty much everything is working the same way as in math, the one that you learned before. Okay, and the last thing here, so we are saying that number is going to, yeah, let's define them all in the same style, large. And here is going to be in the same style, largest. Yeah. So, and what we have here, yeah, I'm missing one more arrow. It's a bit time consuming. It may take up to a few minutes to draw it from the very beginning, but once you have some flow charts already defined, yeah, later on in future, it's getting really easy to draw once you have your, again, defined template, yeah? And in case if the condition is not met, yeah, the number is not larger than 0 anymore, we output total. And this is pretty much all. This is the end. I think just selecting it and copy pasting in the document would work out. I'm not really sure. We're going to find it out in a couple of seconds. Did it work out? It did not. It did not. But what we can do, as far as I know, it's definitely working here. Yeah. So let me copy it again, paste it here. Yeah, so I can paste it in Google presentation slides. Then from slides, yeah, and we have it here. Yeah, I hope it's obvious for you how the flowchart is working, how flowchart is working, and how to draw them using the tool. Yeah, so for today, these are pretty all things that I wanted to talk to you about. Next time, we're going to talk about strings, pseudocode for strings, how to define it, how to define pseudocode for lists and for subroutines as well. Yeah, it's going to be a bit more complicated in the end of the lesson. After the lesson, obviously, I mean, I'm going to post the presentation within a couple of hours, the video and the notes for the video. And also I will generate a few exercises for you based on this, what you had here, to try to practice to solve it on your own. Let me know if you have any more questions left. Yeah, I'm reading the chat. I can see you fully. In case if no more questions left, then we are going to obviously move to the end of our session. I'm thankful for you to come here today and join this session. Yeah, yeah.